section 8, we're going to continue looking at graphing trig functions, but now we're going to look at graphing their transformations. So the first one that we're going to deal with is dealing with the horizontal translation, and then we'll look at a vertical translation later on. So first off, our horizontal translation is going to be what we call a phase shift. Phase shift just meaning that I'm shifting either left or right. And this is going to be opposite of whatever you would think. Remember, even if I was dealing with, going back to an example that we remember, if I was giving you x plus 2 squared minus 4, for example, inside of our parentheses would tell us that's how much we were shifting left or right, and then outside would be how much we're shifting up or down. Well, remember, inside the parentheses, whenever we shift left and right, it is opposite of what we would think. So even though this says plus 2, it's really saying that I'm shifting negative 2. So I'm shifting 2 to the left. And then obviously, if I'm on the outside, I am following my intuition. This one would say down 4. Okay, we're going to start with this idea first, shifting left and right. So think opposite of whatever is given to you. Let's try one that deals with sine. It says state the amplitude, period, and phase shift for y equals sine of theta minus 90 degrees, and then we'll graph the function. So we learned about amplitude and the period in last section. Now we're adding in the phase shift for this example. So again, we find our amplitude in front of our trig function. So this is really saying y equals 1 sine. So 1 would be considered our amplitude. Our period, our normal period for a sine function we learned was 360. We would take whatever this b value is in here. In this case, the b value is 1 because I've got sine 1 and then theta. So 360 divided by 1 is still 360. And then our phase shift. This is where this 90 degrees comes into play. Notice how it's minus 90. If it's minus 90, that means I shifted 90 degrees to the right. So since I moved to the right, we would say it's a positive 90. Now that we know our amplitude, period, and phase shift, we can graph our trig function. I'm going to start with the amplitude. The amplitude we know goes up to a height of 1 and a low of -1. And now, normally on a sine function, we start at 0. Well, since I'm translating it 90 degrees, I'm not really starting at 0, 0 anymore. I'm now going to start at 90 degrees, comma 0, because I shifted my entire function 90 degrees to the right. Once I know my starting location, then I can deal with my period. Remember, every 360 degrees now, we're going to start over. So I'm going to take 90 plus 360. And when I take 90 plus 360, that is going to get me 450 degrees. So between 90 and 450, that's 1 cycle. I would like 2 cycles when you graph. So now I'm going to take 450 plus 360 again, and that's going to get me 810. So between 90 and 810, I'm going to have 2 cycles. We're also going to come up with some other key locations. So I want to find the intercepts. The intercepts we know for a sine function we learned in last section, it is half of whatever our period is. So half of our period would be 360, or 360 divided by 2, which is 180. So I'm going to take really half, which was 180, and I'm going to add it on to 90. And when I do that, we're going to get 270. Another way to find that location is take 90 plus 450 and then divide by 2. That will also get you 270. And then I also want to find halfway in between over here. Again, you can take 450 plus 810 to come up with this value, or you can take 270 and add on a period. That'll get you that value. There's multiple ways to get it, but in this case, if I just take 450 plus 810 and then divide by 2, it's going to get us 630. So in each one of these locations, I am crossing the x-axis. 90, 270, 450, 630, and 810. Draw in my dashed line so I know that I can't cross it. And then for our sine function, what it's going to look like, I'm going to start at this 90 degrees. I'm going to go up towards 1. This is a little difficult. That's what your sine function would look like. If you care to know where these locations are at, up here at the top, it's really halfway between 90 and 270. So again, you could take 90 plus 270, divide it by 2, and that comes out to 180. You could do the same thing over here, 270 plus 450 to find this value, and it's going to come out to 360. And then continuing forward, 450 plus 630, that's going to get, and then divide by 2, that's going to get you 540. And then 630 plus 810 divide by 2, that's going to get you 720. Those would be all the important parts for your sine function.